Imagine a giant blanket stretched on all sides so that it is nice and tight and creates a plane parallel to the ground. Now imagine dropping a marble onto the surface, and then a bowling ball, and then a boulder, and assuming that the blanket doesn't rip, the boulder is going to displace the blanket the most because it has the most mass. Now think of the marble as Earth, the bowling ball as the sun, and the boulder as a black hole. And also think of the blanket as the space-time continuum and displacement from its equilibrium position, or when it doesn't have any mass on it, as the force of gravity. Now one can conclude that the black hole has the largest gravitational pull because it has the most mass. This is the basics of gravity, but now there is much research going into studying black holes by the most celebrated scientists of the 21st century, but even though there's much that scientists do understand, there's also a lot that they don't understand, and there's still research going into their physics, size, their prevalence in the universe, and there's many exciting possibilities which could exist in the black hole. Now, since there's a lot to cover regarding black hole, there are books written on it. Now this speech will explore only some of those aspects, and the points that this speech will explore are how they're formed, how they relate to Einstein's theory of relativity, and of course their prevalence in the universe. Now, to understand what a black hole is, one must first understand the definition of a black hole. Now, Juan Gutierrez described a black hole as a finite region in space during a period of time called space-time, subject to a singularity caused by a concentration of mass in its interior. And according to scientists at NASA, the most common way for a black hole to form is by the aftermath of a supernova explosion. And when a dying star's core is 3 times that of the sun's mass, then it will also form a black hole. And there's another way that black holes have been formed, at least that they've been observed, such as in 2004, scientists at NASA observed a neutron star supposedly colliding with a black hole to form another black hole, and they could notice this because of the gamma ray bursts emitted from there, which are basically very large flashes of light. Now, according to Gutierrez, black holes were explained or predicted by Einstein's theory of general relativity, and they've been studied by scientists such as Carl Schwarzschild and Stephen Hawking and many others, and they've used Einstein's theory of relativity to better understand black holes. Now, according to Stephen Hawking, in his book on black holes and how they relate to the theory of general relativity, a black hole exists in an area known as the event horizon, which is marked by the Schwarzschild radius. And at the Schwarzschild radius, that is the point at which the escape velocity is equal to the speed of light. So basically, anything that passes the Schwarzschild radius into the event horizon cannot escape, not even light. And this is why they're black, because they absorb the light and they can't reflect it. And now, black holes have been explained. It's time to look at how prevalent they are in the universe. And scientists at NASA found that supposedly at the core of the center of every galaxy lies a supermassive black hole. A supermassive black hole can be somewhere from a million to a billion times the size of the sun. So, but they predicted that there are approximately 10 million to a billion black holes in the Milky Way Galaxy alone, and that's including the supermassive black hole presumed to reside in the center of the galaxy. Now, moving on, in conclusion, black holes are an interesting aspect of nature, and physicists of the 21st century have gained extensive knowledge with today's technology, where they've been able to discover supposedly black holes and measure their effects. And it's amazing how a black hole can create a point of infinite density known as the singularity. Now, there is still much to discover about black holes, but that makes it interesting. And who knows, maybe someday black holes can be used to travel through time, or for traveling to other places in space, which would otherwise take millions or billions of years to reach by a rocket.